Tonight, the moon rises exactly as it has for every human being who has ever lived. Appears familiar, dependable, almost permanent. It hangs above cities and oceans, deserts and forests, watching silently as generations come and go beneath its pale light. Most people never question its presence. The moon feels like a fixed part of reality, something that has always existed exactly as it does now. What if that feeling is wrong? Imagine standing on a shoreline so ancient that no trace of it survives today. The waves move in darkness, the air feels different, the world itself is young beyond comprehension. There are no civilizations, no monuments, no stories, and no eyes capable of wondering about the future. Above the horizon, the moon shines over a restless planet still shaping itself, and yet, perhaps it is not alone. For a moment imagine another object nearby, smaller, dimmer but unmistakably present. A second moon drifting through the same sky. A silent companion sharing the heavens with the larger world that would one day become the moon we know. It sounds like the beginning of a myth. The kind of story ancient people might have invented to explain strange lights in the night. Yet some of the most intriguing mysteries often begin where imagination and evidence briefly meet. The deeper scientists look into Earth's earliest history, the stranger that history becomes. Entire continents have vanished without leaving clear records behind. Oceans have appeared and disappeared. Mountains have risen and been worn away until nothing remained. The farther researchers travel into the distant past, the more they discover that permanence is often an illusion. Even things that seem eternal may have experienced forgotten transformations. The sky itself is no exception. For centuries, humanity viewed the moon as a simple object, Earth's companion, a familiar world circling above us. Modern investigations have revealed details that do not fit quite as neatly as once believed. Certain features on the lunar surface appear unusual. Some regions differ dramatically from others. Patterns emerge that seem to hint at a more complicated story hidden beneath the visible landscape. At first, these clues appeared disconnected, a strange crustal difference here, an unexplained feature there, nothing dramatic enough to rewrite history. Yet science has a habit of following small mysteries wherever they lead. As observations improved and computer simulations became more powerful, unexpected possibilities began to emerge. Researchers attempting to reconstruct the moon's distant past sometimes found themselves facing surprising results. In certain scenarios, the story did not end with a single moon forming around Earth. Instead, something more complicated appeared. Something that challenged assumptions people had rarely questioned. The idea seemed almost too strange to take seriously. What if Earth once had two moons? Two moons for a few days or a few years, but two moons sharing the same system during the chaotic youth of our planet. One larger, one smaller, both born from ancient events now buried beneath billions of years of time. And then comes the most fascinating possibility of all. According to a theory proposed by some researchers, the moon visible tonight may not be the whole story. It may be the survivor of an ancient encounter, a collision so old that nearly every direct trace has vanished. If that interpretation is correct, another moon once orbited Earth before disappearing almost completely from history. Almost completely. Because if a lost moon truly existed, the clues may still be there, hidden within the moon itself. Understand how such an extraordinary possibility could even exist, the story must travel back to a time when Earth was not yet the stable world we know today, but a place of fire, violence, and creation. To understand how Earth might once have possessed two moons, it is necessary to travel back to a time when neither the moon nor the Earth we recognize today fully existed. The journey leads more than 4 billion years into the past, to an age when the solar system was not a collection of stable worlds moving peacefully through space. It was a construction site filled with chaos. Young planets drifted through clouds of debris. Fragments of rock and metal crossed unstable orbits. Collisions were common. Survival was uncertain. Familiar order seen today had not yet emerged. Earth was still growing. With each impact, the planet changed. Massive objects struck its surface, delivering energy powerful enough to melt rock and reshape entire regions. Oceans had not settled into their modern forms. Continents had not appeared. The world was a restless sphere of heat and transformation. Then something extraordinary happened. According to the leading explanation accepted by many scientists, a body roughly the size of Mars crossed paths with the young Earth. The collision that followed ranks among the most violent events in our planet's history. The force released was beyond ordinary imagination. Entire regions were vaporized. molten material blasted into space. Brief period, Earth may have been surrounded by a glowing cloud of debris stretching far above its surface. Out of destruction came creation. Over time, countless fragments began gathering together. Gravity slowly pulled scattered material into larger clumps. Those clumps merged with others. Gradually, a new world emerged from the aftermath of catastrophe. That world became the Moon. For years, this explanation seemed remarkably successful. It accounted for many features observed by scientists and helped explain why Earth and the Moon share certain similarities. The story appeared complete. Sometimes the most interesting mysteries begin after a solution has already been accepted. As computer technology improved, researchers gained the ability to recreate ancient planetary events in extraordinary detail. They could simulate collisions, track debris, and observe what might happen during the chaotic birth of a moon. Many expected these simulations to reinforce the familiar picture. Instead, some produced surprises. Again and again, certain models revealed outcomes that were not quite so simple. The debris surrounding Earth did not always gather into a single moon-forming body. To specific conditions, multiple objects appeared. Some remained small, others grew larger. Occasionally, the simulations generated something unexpected. More than one moon. Possibility was difficult to ignore. After all, the solar system offers countless examples of planets accompanied by multiple moons. Jupiter possesses dozens, Saturn possesses even more. Around those giant worlds, entire families of moons travel together through space. Seen from that perspective, a planet with multiple moons is not unusual at all. The real question becomes something else. Why assume Earth was always different? Why assume the chaotic forces capable of creating many moons elsewhere somehow produced only one here? The answer, surprisingly, is that scientists cannot completely assume that. As researchers continued exploring lunar formation models, some discovered scenarios in which a smaller companion naturally formed alongside the larger moon. Not a permanent twin, but a genuine second lunar body sharing Earth's neighborhood. The idea emerged not from mythology or speculation, but from attempts to understand how planets and moons actually form. Suddenly, the mystery changed. The notion of a missing moon no longer seemed like an impossible fantasy. It became a scientific possibility rooted in the same physics that shaped the rest of the solar system. If a second moon could form, however, an even more intriguing question follows. Did any evidence survive the passage of billions of years, hidden somewhere on the moon itself? The mystery now leaves the ancient Earth behind and turns its attention toward the moon itself. From a distance, the moon appears simple. Its pale surface seems familiar, almost unchanging. Generations have looked upward and seen the same bright companion crossing the night sky. It is easy to imagine it as a perfectly ordinary sphere, silent and straightforward. Yet the closer scientists examine it, the stranger it becomes. The moon is not as symmetrical as it first appears. Beneath its calm exterior lies a collection of differences that have puzzled researchers for decades. Some are subtle, others are surprisingly dramatic. Together, they suggest that the moon's history may be far more complicated than its appearance allows. One mystery stands above the rest. Most people never see the moon's far side, permanently faces away from Earth, hidden from view until spacecraft finally revealed it during the 20th century. When those first images arrived, scientists expected a world similar to the side already familiar to humanity. Instead, they found something unexpected. The hidden hemisphere looked different. Its landscape contained fewer of the large dark plains visible on the near side. Mountainous terrain appeared more extensive. More intriguingly, measurements revealed that the crust on the far side was significantly thicker than the crust facing Earth. The difference was not small. For decades, researchers have attempted to understand why one half of the moon should possess such a dramatically different structure from the other. If the moon formed as a single object, why should one side carry so much additional material? Question became a scientific detective story. Investigators examined ancient volcanic activity. Perhaps molten rock had behaved differently across the lunar surface. Others explored cooling patterns from the moon's earliest history. Maybe temperature differences produced uneven development. Still others studied the scars left by impacts, searching for evidence that colossal collisions had altered one hemisphere more than the other. Each explanation offered valuable insights, yet none seemed capable of completely resolving every aspect of the puzzle. Deeper researchers looked, the more the mystery lingered. Then an unusual possibility emerged. What if the answer was not hidden within the moon alone? What if another world was involved? According to one intriguing model, the thick crust on the far side may be the consequence of an ancient encounter between two moons. In this scenario, a smaller companion moon orbited Earth alongside the larger moon billions of years ago. Over immense spans of time, gravitational interactions gradually altered its path. Eventually, the smaller body drifted closer. Most people imagine cosmic collisions as explosive disasters, with worlds smashing together at extraordinary speeds. This model suggests something different. The encounter may have occurred relatively slowly by astronomical standards. Instead of shattering both objects, the smaller moon could have merged with the larger one. Consequences would have been remarkable. Material from the companion moon would spread across one hemisphere, piling layer upon layer onto the surface. Rather than leaving behind a dramatic crater, the collision could effectively add an enormous amount of crust to one side of the moon. Suddenly, a long-standing geological mystery gains a surprising explanation. The unusually thick far side may not simply be part of the moon's original structure. It may be a monument to another world. For many people, this idea produces a moment of genuine astonishment. Possibility feels almost impossible at first. Yet it emerges from attempts to explain real observations, not from fantasy. A missing moon, once little more than an intriguing concept, now appears connected to physical features that scientists can actually study. Of course, the mystery remains unresolved. Alternative explanations continue to compete for attention. Evidence can be interpreted in different ways. Researchers continue debating which scenario best matches reality. Something important has changed. The question is no longer whether the idea is interesting. The question is whether the clues scattered across the moon are telling the story of a vanished companion. And if a second moon truly existed, the next challenge is understanding how it survived for so long, what path it followed around Earth, and what invisible forces eventually guided it toward its extraordinary fate. Imagine standing on Earth at a time so distant that even the oldest surviving rocks cannot fully remember it. Continents of today do not exist. Familiar coastlines have not yet formed. If present at all, remains simple and fragile. The world feels alien, yet the sky above holds something even more remarkable. Night arrives. Darkness spreads across the young planet, and a bright moon rises above the horizon. At first, the scene appears familiar. Its pale light reflects across ancient waters much as it does today. Then another shape emerges, smaller, dimmer, yet unmistakably present. A second moon hangs in the sky. Brief moment, the idea feels almost dreamlike. Humanity has known only one moon throughout recorded history. Calendar, myth, poem, and story has been written beneath its solitary glow. The notion of two moons seems as though it belongs to fantasy rather than reality. And yet some scientific models suggest that such a sky may once have existed. If a smaller lunar companion formed alongside the larger moon, Earth could have spent millions of years beneath a pair of celestial neighbors. They would not necessarily have appeared side by side every night. Their movements would differ. Sometimes both might be visible. At other times, one could dominate the heavens while the other lingered elsewhere in the darkness. The sight would have transformed the appearance of the sky. Moonlight might arrive from different directions. Shadows could behave in unfamiliar ways. Ancient oceans would respond to the combined pull of two lunar bodies. Even the rhythm of tides may have carried patterns unlike anything experienced on modern Earth. Yet the most intriguing part of the story is not simply that two moons might have existed, it is how they may have remained together. Gravity is often imagined as a force that pulls objects directly toward one another. In reality, it can create surprisingly delicate arrangements. Under certain conditions, regions of temporary balance emerge where competing gravitational influences offset one another. These locations are known as Lagrange points. They are not places where gravity disappears. Instead, they are places where motion and attraction reach a fragile compromise. Some researchers have suggested that a smaller companion moon may have occupied one of these regions relative to Earth and the larger moon. There, it could have traveled in a shared orbital relationship, neither escaping into space nor immediately colliding with its larger neighbor. Millions of years, the arrangement may have appeared remarkably stable. The two moons would continue their silent journey around Earth, locked in a gravitational dance established during the chaotic youth of the solar system. To an observer standing below, the heavens might seem settled and permanent, but permanence can be deceptive. History of the solar system repeatedly demonstrates that stability is often temporary. Worlds drift, orbits evolve, tiny influences accumulate over immense spans of time. Peers unchanged during one age may transform entirely during another. This realization changes how the audience views the ancient Earth. Planet was not a finished world waiting for life to arrive. It was a dynamic environment where enormous changes unfolded over timescales almost impossible to imagine. Oceans shifted, atmospheres evolved, planetary surfaces transformed. Even the sky overhead may have been very different from the one humanity eventually inherited. The existence of a second moon, if it occurred, would be another reminder that the early solar system was far stranger than the orderly version visible today. Yet an important question remains. If two moons truly shared Earth's sky for millions of years, why did the arrangement not survive? The answer may lie in one of the most powerful lessons astronomy has ever revealed. In space, even the most balanced systems are rarely motionless. Invisible forces are always at work, making tiny adjustments that seem insignificant at first. And sometimes, those tiny adjustments change everything. If two moons once shared Earth's sky, their story was never destined to be defined by dramatic explosions or sudden catastrophe. Instead, it was shaped by something far quieter, something invisible, something so familiar that it is easy to overlook despite governing the movement of entire worlds. Gravity. Most people think of gravity as a force that pulls objects downward. Yet on the scale of planets and moons, it behaves more like a patient sculptor, slowly reshaping the architecture of the cosmos. It works continuously, never rushing, never pausing, making tiny adjustments that accumulate across unimaginable spans of time. In the early Earth-Moon system, gravity would have been everywhere. It bound the larger moon to Earth. It influenced the smaller companion. It connected both worlds to the Sun and linked them to countless other bodies moving through the solar system. Every object exerted some degree of influence, however slight. No orbit existed in complete isolation. This is why astronomers often describe orbital systems as dances rather than fixed arrangements. Nothing remains perfectly still. Even when motion appears stable, subtle changes are occurring beneath the surface. Positions shift, velocities evolve, gravitational relationships adjust. Most of these variations are far too small to notice during a human lifetime. A person watching the sky for decades might never detect them. But millions of years tell a different story. Imagine the smaller moon occupying a region of temporary balance. For a long time, its orbit remains predictable. It circles Earth in harmony with the larger moon, following pathways established during the solar system's chaotic youth. The arrangement appears secure, then gravity begins its quiet work. A slight pull from the Sun alters the companion's motion by a tiny amount. Gravitational interaction changes its position ever so slightly. Tidal forces continue transferring energy throughout the system. Each influence is almost insignificant on its own, yet none of them disappear. The changes accumulate. One orbit differs slightly from the one before it. Another follows, and another. Thousands become millions, millions become tens of millions. The process unfolds so slowly that it resembles the movement of continents or the erosion of mountains. Nothing dramatic happens in a single moment, yet everything changes over time. The companion moon drifts. Not rapidly. Not enough to inspire alarm. But enough. This is one of the strangest realities in astronomy. Many cosmic disasters begin quietly. Long before worlds collide, long before visible chaos appears, the conditions leading toward catastrophe are already taking shape. The future is being written through movements so small that no observer could recognize their significance. The audience is invited to picture the smaller moon continuing its journey around Earth, unaware of the path gradually unfolding before it. Each orbit carries it through darkness. Each revolution seems ordinary. Yet gravity is patiently guiding events toward a destination neither moon can avoid. Researchers exploring this possibility through computer simulations have uncovered a fascinating pattern. In some models, the smaller companion eventually escapes the stable region that once protected it. The delicate balance begins to weaken. Its path slowly evolves into something new and something dangerous. Rather than remaining safely separated, the companion moon starts moving closer to the larger moon. The distance between them decreases little by little. What once seemed like a permanent arrangement becomes increasingly fragile. The realization is unsettling. The world may not need a violent external force to seal its fate. Sometimes gravity alone is enough. Not because it acts suddenly, but because it never stops acting at all. By the time the companion moon begins drifting toward its larger neighbor, the outcome may already be written into the mathematics of the system. Process remains slow, almost peaceful. Yet beneath that calm surface, an ancient collision is drawing nearer. With every orbit, an entire world moves one step closer to disappearing forever. Millions of years, the smaller moon drifted through space under the quiet influence of gravity. Its orbit evolved slowly. The distance separating it from its larger companion gradually diminished. No sudden disaster announced itself. No dramatic warning echoed across the solar system. Yet an ending was approaching. By the time the two worlds drew close, their story had already been unfolding for ages beyond human comprehension. Countless orbits had passed. Entire chapters of planetary history had come and gone. Collision, when it finally arrived, was not the beginning of the catastrophe. It was the final sentence in a story gravity had been writing all along. People imagine planetary collisions as violent spectacles. The image is easy to understand. Two massive worlds race toward one another. The impact releases unimaginable energy. Rock vaporizes. Debris explodes into space. Entire landscapes are erased in moments. And certainly, many collisions throughout the solar system have looked exactly like that. Some researchers believe the fate of Earth's hypothetical companion moon may have been very different. According to certain simulations, the encounter may have occurred at a surprisingly low relative speed. Cosmic standards, the smaller moon was not rushing toward destruction. Instead, it approached its larger neighbor almost gently. Collisions still involved extraordinary forces beyond anything experienced on Earth today, yet compared to many planetary impacts, it was remarkably slow. This difference changes everything. Rather than instantly shattering both bodies, much of the smaller moon's material may have remained intact. Instead of being blasted away into space, enormous quantities of rock could have spread across the surface of the larger moon. Layer upon layer accumulated over one hemisphere, gradually becoming part of the world that survived. The event was still catastrophic. An entire moon ceased to exist as an independent object, yet it disappeared in an unexpectedly quiet way. There was no vast field of fragments left orbiting Earth, no second moon lingering as a broken remnant, no obvious scar visible from Earth that would forever announce what had happened. One world simply merged into another. The result was less like an explosion and more like an absorption. This possibility has fascinated researchers because it offers a potential explanation for several unusual features observed on the moon today. Scientists running simulations of low-velocity lunar mergers discovered outcomes that looked surprisingly familiar. The distribution of material resembled certain structures found on the moon. The unusually thick crust on the far side became easier to explain. Some topographical differences appeared less mysterious. The pieces began fitting together. Not perfectly, conclusively, but enough to attract serious attention. As lunar missions gathered increasingly detailed measurements, scientists compared those observations against the results produced by their models. Again and again, they asked the same question. Could part of the moon actually be the remains of another moon? The answer remains uncertain. Alternative explanations still exist. Competing theories continue to challenge the merger scenario. Science has not reached a final verdict. Yet the possibility refuses to disappear because the clues themselves remain. And those clues lead to a remarkable realization. If this collision occurred more than 4 billion years ago, almost every direct trace would have vanished long ago. Time is extraordinarily effective at hiding ancient events. Small details disappear. Evidence erodes. Histories become increasingly difficult to reconstruct. The surviving moon would continue orbiting Earth as though nothing unusual had happened. Generations would look upward and see only a single lunar world. Civilizations would rise and fall beneath its light. Myths would be written. Calendars would be created. No memory of a companion moon would survive. Only a few subtle fingerprints might remain, hidden within the moon's geology. That is what makes the mystery so captivating. A world may have vanished directly above Earth without leaving behind a dramatic monument to its existence. Instead, it may have disappeared so completely that only fragments of evidence remain scattered across the surface of the moon itself. Yet another question now emerges from the darkness. If two moons once circled Earth, perhaps their story was written not only in lunar rock, but also in the ancient history of our own planet. The mystery of the missing moon becomes even more intriguing when attention shifts away from the sky and back toward Earth itself. If a second moon truly existed, its influence would not have ended at the edge of space. It would have reached downward, touching the oceans, shaping coastlines, and perhaps affecting the conditions under which life emerged. Connection begins with something familiar. Tides. Most people rarely think about them. The ocean rises. The ocean falls. The cycle feels so natural that it is easy to forget how extraordinary it truly is. Every day, vast quantities of water move across the surface of the planet because of a distant object hanging in the sky. The moon does not simply illuminate the night, it pulls on the Earth. Pull is subtle when experienced by a single person, yet powerful enough to raise and lower entire oceans. Beaches disappear beneath advancing water and then reappear hours later. Lines breathe in a rhythm established by gravity. Now imagine adding another moon. Even if the companion were significantly smaller than the moon we know today, its gravitational influence would still matter. Oceans are remarkably sensitive to such forces. Small changes can produce surprisingly large consequences when repeated over immense spans of time. In a world with two moons, tides might not follow the familiar patterns experienced today. Sometimes the gravitational pulls could reinforce one another, creating stronger movements of water. At other times, the effects might partially cancel. Complex cycles could emerge, producing rhythms unlike anything visible on modern Earth. Ancient shorelines may have experienced a constantly changing interplay of rising and falling seas. Scientists attempting to understand these possibilities often rely on models rather than certainty. No one can travel back billions of years to observe those oceans directly. Instead, researchers explore scenarios, adjusting variables and studying how different arrangements might influence the young planet. The results raise fascinating questions. Could stronger tidal activity have increased the mixing of coastal waters? Might nutrients have circulated more efficiently between shallow and deeper environments? Could regions rich in chemical building blocks have been stirred together more frequently than they otherwise would have been? These questions matter because Earth's earliest oceans were not merely bodies of water. They were environments where countless chemical interactions occurred. Long before plants covered the land or animals moved across continents, the seas hosted processes that eventually contributed to the emergence of life. The exact path from chemistry to biology remains one of science's greatest mysteries. Yet many researchers agree on one point: the environment matters. Conditions that concentrate chemicals, cycle materials, and encourage repeated interactions can influence what becomes possible. Tides are particularly interesting because they create boundaries between wet and dry conditions. Pools fill and empty. Minerals dissolve and accumulate. Compounds that might otherwise remain dispersed are brought together. This leads to one of the most intriguing possibilities in the entire story. Some scientists have suggested that tidal environments may have played a role in concentrating organic compounds important to the earliest stages of life's development. The idea remains debated, but it highlights the profound influence that gravitational forces can have on a planet's history. If that possibility contains even a fragment of truth, then the missing moon takes on a very different significance. It is no longer merely an object that may have vanished from the sky. It becomes part of Earth's story, participant rather than a spectator. Its gravitational pull may have helped shape coastlines, influence ancient oceans, and contribute to environments where crucial chemical processes unfolded. The effects would not have been dramatic from one day to the next. Like so many forces in planetary history, they would have accumulated slowly, almost invisibly. And yet, over millions of years, invisible influences can leave lasting marks. Question now becomes even larger than the mystery of a missing moon. If two moons may have altered Earth's oceans, what other changes might they have introduced? Because gravity affects more than water alone. It also influences the movement of entire planets, quietly shaping the rhythm of days, the stability of worlds, and the future of everything that follows. Every sunrise feels predictable. The sun appears above the horizon. Hours pass. Darkness arrives. The cycle repeats with such consistency that most people rarely stop to consider it. A day seems like one of the most permanent features of existence, fixed and unchanging. Yet the length of a day has not always been what it is now. To understand why, it is necessary to imagine an Earth very different from the modern world. Billions of years ago, the planet rotated far more quickly. The familiar 24-hour cycle did not exist. The young Earth spun with greater speed, carrying oceans, clouds, and continents through shorter days and more frequent nights. If a visitor could somehow stand upon that ancient world, the passage of time itself would feel different. Sunrises would come sooner, sunsets would arrive more often, the rhythm of the planet would be faster, more energetic, and constantly evolving. At first glance, this may seem unrelated to the mystery of a missing moon, yet the connection runs deeper than it appears. The moon is not merely Earth's companion, it also acts as a subtle influence on the planet's rotation. In a sense, the moon functions as a brake, not a sudden brake, not one capable of stopping Earth's spin. Instead, it works through an extraordinarily slow process driven by tidal interactions. As the moon's gravity pulls on Earth's oceans, energy is gradually transferred within the Earth-Moon system. Over immense stretches of time, this process slightly slows the planet's rotation. The effect is almost impossible to notice during a human lifetime. Yet over billions of years, it becomes profound. The Earth spinning beneath our feet today is rotating more slowly than the Earth that existed during the planet's youth. Every day is a little longer because of a process that has been operating continuously for ages. Now the mystery becomes more interesting. What if there were two moons? If a smaller companion once orbited Earth alongside the larger moon, additional tidal forces would have existed within the system. The exact consequences remain uncertain, but researchers have explored how multiple lunar bodies might influence the exchange of energy between Earth and its satellites. The differences may have been subtle. Perhaps the planet lost rotational energy slightly faster. Perhaps certain interactions produced effects that varied over time. Perhaps the influence was relatively minor. No one knows with certainty. Yet the possibility itself transforms something familiar into something extraordinary. The length of a day, something most people never question, may be connected to events that unfolded billions of years ago in the skies above a young Earth. The audience is invited to imagine the cumulative power of tiny influences. A slight gravitational tug seems insignificant. A small adjustment in orbital dynamics appears trivial. Planetary history is often shaped by precisely such forces. They operate continuously, adding their effects together across spans of time so vast that even the smallest changes become meaningful. This is one of the most fascinating lessons hidden within the story of the missing moon. Worlds do not always change through dramatic catastrophes. Sometimes they are transformed by processes so gradual that no individual generation could ever witness the full result. The difference between one moon and two may appear minor when viewed over days or years. Viewed across billions of years, however, the consequences could become enormous. Of course, uncertainty remains. Scientists can construct models, they can explore scenarios and compare outcomes. Direct evidence from such remote periods is extraordinarily difficult to obtain. Much of Earth's earliest history has been erased by geological activity, leaving researchers to reconstruct the past from fragments and clues. And so, the possibility lingers. A vanished moon may have helped shape not only the oceans but also the rhythm of the planet itself. Every sunrise, every sunset, every 24-hour cycle may be part of a story far older than humanity. And if two moons influenced Earth's rotation, another question naturally follows. Could they also have affected the planet's long-term stability, quietly shaping the balance that allowed Earth to become the world we know today? Imagine once more looking upward into the sky of the ancient Earth. Two moons drift through the darkness. One dominates the heavens, bright and familiar. The other follows a different path, smaller yet impossible to ignore. Their light reflects across oceans, glimmers over primitive coastlines, and illuminates a world that bears only a distant resemblance to the planet known today. The image is captivating, but the significance of two moons may extend far beyond their appearance. Throughout this journey, the focus has often centered on visible effects. Tides rise and fall, oceans shift, the length of a day gradually changes, yet some of the most important influences of a moon are not immediately obvious. Occur slowly, operating in the background of planetary history. One of those influences involves Earth's tilt. The planet does not spin perfectly upright. Its axis is inclined, causing different regions to receive varying amounts of sunlight throughout the year. This tilt is responsible for seasons, shaping climate patterns across the globe. First, that arrangement may seem stable and permanent. In reality, planetary tilts can change. Without stabilizing influences, those changes can sometimes become dramatic. The planet might experience significant shifts in orientation over long periods of time, leading to major climatic consequences. Regions that were once temperate could become far colder or warmer. Environmental conditions might fluctuate in ways that challenge the development and persistence of life. The Moon plays an important role in limiting such instability. Decades, scientists have recognized that Earth's large moon helps moderate variations in the planet's axial tilt. It does not eliminate change entirely, but it contributes to a level of long-term stability that has influenced Earth's environmental history. Now, the mystery introduces a fascinating complication. What happens if there are two moons instead of one? First glance, the answer might seem obvious. More moons should create more stability. More gravitational influence should strengthen the system. Yet the universe often refuses to follow simple expectations. Researchers investigating multiple moon scenarios have discovered that outcomes can be surprisingly complex. In some models, additional gravitational interactions appear relatively harmless. In others, they introduce new patterns of behavior. The effects depend on orbital distances, masses, positions, and countless subtle relationships that evolve over time. A second moon does not automatically make the system more orderly. Sometimes it makes it more complicated. This realization changes the nature of the mystery once again. The audience begins to understand that Earth's history may have depended upon a delicate balance of forces. Presence of an additional moon could have influenced that balance in ways that remain difficult to reconstruct. Some effects may have been beneficial, others may have introduced instability. Many possibilities remain uncertain. What becomes clear is that the early Earth was not guaranteed to evolve exactly as it did. The world we inhabit today often feels inevitable. Oceans exist where they do, seasons arrive on schedule. Climate systems operate within familiar limits. Humanity tends to view these conditions as normal because they are all we have ever known. Normality can be deceptive. The farther scientists look into the past, the more they encounter evidence of contingency. Tiny differences in initial conditions can produce vastly different outcomes. Small changes accumulate. Alternative paths emerge. Entire worlds can evolve in unexpected directions. The story of a possible second moon fits within that larger theme. Perhaps it influenced Earth's development in measurable ways. Perhaps its effects were subtle. Perhaps some of its influence disappeared when it merged with the larger moon. The answers remain hidden behind billions of years of time. Yet the question itself is powerful. It reminds us that the Earth we know may be only one version of what could have existed. Countless variables shaped its journey from a young, chaotic planet into a world capable of supporting life. Some of those variables remain visible. Others may have vanished from the sky long ago. And if a missing moon truly played a role in Earth's story, the strongest clues may still be waiting where the mystery first began, hidden within the moon itself, patiently awaiting discovery by those determined enough to keep searching. Every mystery leaves traces, a footprint in the mud, a fragment of a letter, a detail that seems insignificant until someone looks at it more closely. Investigators know that the past rarely disappears completely. It hides itself in small details, waiting for someone patient enough to notice. For scientists studying the possibility of a lost moon, the investigation eventually returns to the most obvious place imaginable: moon itself. If another moon once existed and later vanished, then somewhere within the surviving lunar landscape there may still be clues. Dramatic clues, not a giant message written across the surface. Instead, subtle evidence preserved across billions of years. This is where the moon becomes less like a celestial object and more like a crime scene. Unlike Earth, the moon is an extraordinary keeper of history. Our planet constantly rewrites its surface. Winds erode mountains, rivers carve valleys, oceans reshape coastlines. Deep beneath the ground, tectonic forces recycle vast portions of the crust. For enough time, even major events can be erased. The moon lives by different rules. It possesses no oceans capable of washing evidence away, no weather systems gradually wearing down ancient features, no active plate tectonics endlessly rebuilding the landscape. Once something happens on the moon, traces of that event can remain visible for astonishing lengths of time. In many places, the lunar surface preserves records stretching back billions of years. Every crater tells a story. Every mountain range reflects ancient processes. Every layer of crust contains information about a world whose history extends to the earliest chapters of the solar system. For decades, scientists examined those clues with increasingly sophisticated tools. Then a new generation of lunar missions transformed the investigation. Orbiters mapped the moon in extraordinary detail. Instruments measured topography, gravity, composition, and crust thickness with unprecedented precision. The more researchers learned, the more unusual the moon appeared. Certain asymmetries refused to disappear. One hemisphere looked significantly different from the other. The far side possessed a thicker crust. Surface features were distributed unevenly. Patterns emerged that seemed difficult to explain through simple assumptions. Naturally, scientists proposed multiple explanations. Some researchers argued that temperature differences during the moon's earliest history produced uneven development. Others focused on ancient impacts, suggesting that collisions altered the distribution of material across the surface. Additional theories explored volcanic activity and internal geological processes. Each explanation solved part of the puzzle. None solved everything. That is often how scientific mysteries evolve. The evidence rarely points clearly toward a single answer. Instead, competing interpretations struggle to explain the same collection of clues. Then the missing moon hypothesis entered the discussion. The idea was unusual, but it offered something valuable. It provided a potential mechanism capable of explaining several observations simultaneously. If a smaller companion moon merged with the larger moon, enormous quantities of material could have accumulated on one hemisphere. Thick far-side crust suddenly became less mysterious. Still, an idea remains only an idea until it confronts evidence. This is where computer simulations became crucial. Researchers recreated ancient lunar collisions and studied the outcomes. Again and again, virtual moons approached one another, merged and produced new landscapes. The results were then compared with real observations gathered from lunar missions. Something remarkable happened. Some simulations generated structures surprisingly similar to those visible on the moon today. Resemblance was not perfect, it was not proof, but it was enough to attract serious attention. Theory once dismissed as highly speculative now appeared capable of reproducing real features observed on a real world. Possibility of a lost moon moved from the realm of imagination into the realm of scientific investigation. Mystery remained unsolved, yet the evidence seemed increasingly worthy of consideration. And as every good investigator eventually discovers, surface clues are only the beginning. Most important answers are often hidden beneath what can be seen. If scientists truly hope to determine whether another moon once existed, they must look deeper than craters and mountains. They must explore the moon's hidden interior, where some of the oldest secrets may still remain untouched. From Earth, the moon appears deceptively simple. Its familiar face shines across the night sky, revealing craters, dark plains, and bright highlands. Even spacecraft photographs, despite their extraordinary detail, show only the outermost layer of a world whose history stretches back billions of years. Investigators searching for evidence of a lost moon have learned an important lesson. The most revealing clues are not always visible on the surface. Sometimes they are hidden deep beneath it. Modern lunar science has entered an era that would have seemed impossible only a few generations ago. Researchers no longer rely solely on photographs and telescopes. Orbiting spacecraft measure gravity with astonishing precision. Instruments map crust thickness, analyze density variations, and examine structures buried beneath ancient terrain. The result is a new way of studying the moon. Scientists are not simply observing what exists today. They are attempting to reconstruct events that happened billions of years ago, using traces hidden within the moon's interior like clues preserved inside an ancient archive. Process resembles detective work. A subtle gravitational anomaly appears in one region. Unexpected difference in crust thickness emerges elsewhere. Certain materials seem distributed unevenly across the lunar surface. Individually, these observations may not seem remarkable. Together, they begin to suggest that the moon's history was more complicated than once assumed. Many of these patterns remain difficult to explain completely. Researchers continue debating their origins. Some may result from internal geological processes. Others could reflect ancient impacts or variations present during the moon's formation. Yet a few observations align surprisingly well with models involving a long-lost companion moon. Possibility keeps the mystery alive. One reason the investigation remains so challenging is that scientists may be searching for evidence of an event specifically suited to hiding itself. People imagine collisions leaving dramatic scars. A giant impact should create an enormous crater. Catastrophic encounter should scatter debris and produce unmistakable destruction. Proposed lunar merger tells a different story. If a smaller moon slowly collided with the larger moon, the event might not create the obvious signatures associated with high-speed impacts. Much of the material could merge rather than explode. Instead of generating a single spectacular scar, the collision might leave behind subtle structural changes distributed across an entire hemisphere. Fingerprints would exist, but they would be difficult to recognize. This creates one of the most fascinating aspects of the mystery. The absence of dramatic evidence does not automatically mean the event never happened. In fact, if the merger model is correct, scientists should expect exactly this kind of ambiguity. They are not searching for a smoking gun. They are searching for patterns, tiny inconsistencies, measurements that seem slightly unusual, features that become meaningful only when viewed together. The audience begins to appreciate how difficult the challenge truly is. Researchers are attempting to identify the remains of a world that may have disappeared more than 4 billion years ago. They must do so using evidence altered by immense stretches of time and preserved within a body that has experienced countless other events since then. And yet, despite those obstacles, intriguing clues continue to emerge. Certain regions of the Moon possess characteristics that remain puzzling. Some structures appear more consistent with merger scenarios than expected. Certain distributions of material raise questions that have not yet received universally accepted answers. None of this proves the existence of a second moon. That uncertainty remains essential to the story. Uncertainty does not weaken the mystery. If anything, it strengthens it. The audience realizes that science often advances through questions rather than conclusions. Every unexplained feature becomes an invitation to look deeper. The investigation therefore continues beneath the surface, within the moon's hidden structure, and inside the data collected by modern missions. Yet geology alone may never solve the puzzle. To truly test whether a lost moon once existed, scientists must attempt something even more ambitious. They must recreate ancient events themselves, building virtual worlds and allowing them to evolve across billions of years. Only then can they discover whether the clues hidden inside the moon match the story the universe may have written long ago. There is a fundamental problem at the heart of the missing moon mystery. No human witnessed the events in question. No telescope recorded them. No ancient civilization preserved a memory of them. Possible birth, evolution, and disappearance of a second moon occurred billions of years before the first human ever looked toward the sky. If direct observation is impossible, how can such a mystery be investigated at all? The answer lies in an unexpected form of time travel, not through machines or impossible technology, but through mathematics. Modern scientists possess tools capable of recreating ancient worlds inside computers. These simulations do not rely on imagination alone. They are built from the laws of physics that govern the universe today. Gravity behaves according to measurable rules. Matter follows predictable principles. Motion, energy, and collisions can all be described mathematically. When those rules are combined with powerful computers, something remarkable becomes possible. Researchers can reconstruct the distant past. The process begins with a virtual solar system. Scientists enter known information about the young Earth, the Moon, and the conditions believed to have existed billions of years ago. They adjust variables. They test different assumptions. Then they allow the simulation to evolve. What happens next is often unpredictable. Some virtual worlds quickly collapse into unrealistic outcomes. Moons drift away. Collisions occur too violently. The resulting structures bear little resemblance to reality. These models are valuable because they eliminate possibilities, showing researchers which paths are unlikely. Other simulations produce something more interesting. Patterns begin to emerge. Moons form from debris surrounding the young Earth. Orbital relationships develop. Gravitational interactions unfold across millions of virtual years. The audience is invited to imagine researchers watching entire chapters of planetary history pass before their eyes in accelerated time. Again and again, worlds are created. Again and again, they evolve. Most importantly, they can be compared against the moon visible today. This comparison is what transforms simulations from simple experiments into investigative tools. Every virtual outcome is measured against reality. Does the resulting moon possess the correct structure? Does its crust resemble actual observations? Do its features align with data gathered by lunar missions? Closer the match, the more interesting the scenario becomes. One of the most fascinating discoveries emerged when scientists explored models involving multiple lunar bodies. Under certain conditions, Simulations naturally produced a smaller companion moon alongside the larger moon. The arrangement persisted for extended periods. The moons interacted gravitationally, evolving together through time. Then something extraordinary happened. The smaller moons slowly approached the larger one. A collision followed. Not the dramatic destruction often imagined in popular depictions of cosmic impacts, but a slower merger capable of redistributing material across one hemisphere. The resulting world displayed characteristics surprisingly similar to features observed on the modern moon. Thick far-side crust became easier to explain. Certain asymmetries appeared less mysterious. The resemblance was striking enough to capture scientific attention. For supporters of the missing moon hypothesis, these results represented an important milestone. A theory that once seemed highly speculative could now generate realistic outcomes using the same physical laws governing the solar system. Yet an important distinction remains. Simulations can demonstrate possibility, they cannot establish certainty. This is where the mystery retains its power. Computer model may successfully recreate features observed on the moon, but that does not prove events unfolded exactly that way. Nature often allows multiple explanations for the same result. Different histories can sometimes produce similar outcomes. Scientists therefore find themselves balancing evidence against uncertainty. The simulations are compelling. The geological clues are intriguing. The pieces fit together more comfortably than many expected. The final answer remains just beyond reach. Still, something important has changed. The missing moon is no longer merely an interesting idea. It has become a scientifically plausible scenario supported by observations, models, and physical principles. Whether it represents reality remains unknown, and that uncertainty leads to an even larger question. If a vanished moon could exist in Earth's past, perhaps such events are not unusual at all. Perhaps the disappearance of worlds is not an exception, but part of a much broader pattern woven throughout the history of the solar system itself. The mystery of a missing moon feels extraordinary when viewed from Earth. A world forms. It survives for millions of years, then it vanishes so completely that only a few possible traces remain. At a glance, such a story appears rare, perhaps even unique. It seems like the sort of event that should stand apart from ordinary planetary history. That impression begins to change the moment the audience leaves Earth behind. The scale expands. The viewpoint rises above the moon, beyond our planet, and out into the vast architecture of the solar system itself. Suddenly, the mystery no longer appears isolated. Instead, it becomes part of a much larger story, one written through violence, collision, and transformation. Today, the solar system appears calm. Planets move along predictable paths, moons circle their parent worlds. Everything seems stable, almost permanent. The orderly arrangement creates the illusion that it has always existed this way. Yet appearances can be misleading. The early solar system was nothing like the peaceful environment visible today. More than 4 billion years ago, it resembled a crowded construction site filled with unfinished worlds. Clouds of debris drifted through space. Newly formed planets competed for territory. Countless objects crossed unstable paths. Collisions occurred with astonishing frequency. Survival was never guaranteed. Many of the worlds that existed during that era no longer exist at all. Some were shattered, others merged together. Many disappeared so completely that their former existence can only be inferred from subtle clues preserved within surviving objects. This realization transforms the way scientists view planetary history. Formation and destruction are not separate processes. In many cases, they are the same process observed from different perspectives. Collision destroys one world while creating another. A merger erases identities while producing something new. What appears to be an ending often becomes the beginning of an entirely different story. The evidence for this pattern can be found throughout the solar system. Mercury carries scars from an ancient past that may have involved enormous impacts. Some researchers suspect the planet lost a significant portion of its outer layers during violent collisions long ago. Mars preserves evidence of catastrophic events that reshaped its surface and altered its evolution. The Moon itself almost certainly owes its existence to a colossal impact during Earth's youth. Even the asteroid belt may represent the remains of processes that prevented larger worlds from fully forming. Everywhere scientists look, they find signs of destruction. Yet those signs also reveal survival. The objects visible today are not pristine relics untouched by history. They are survivors. Each carries evidence of challenges overcome, transformations endured, and encounters that might easily have ended differently. This leads to one of the most surprising revelations in the entire documentary. A missing moon is not necessarily unusual. When viewed against the backdrop of planetary evolution, disappearance may actually be one of the most common outcomes in cosmic history. Countless worlds likely formed during the solar system's earliest epochs. Many never survived. Some merged with larger bodies, others were shattered into fragments. Some may have been ejected into darkness beyond the sun's influence. The surviving worlds are not the whole story. They are merely the chapters that remain visible. The audience begins to understand that Earth's hypothetical second moon fits comfortably within this larger pattern. If it existed and later disappeared, it would not represent a strange exception to cosmic history. Represent cosmic history behaving exactly as it often does. Worlds appear, worlds change, worlds vanish, and sometimes their disappearance leaves only subtle clues behind. The perspective shift is profound. The mystery is no longer just about a missing moon above Earth. It has become part of a universal process that shaped planets, moons, and entire systems across billions of years. And once that broader pattern becomes visible, a new question emerges. If destruction and transformation are so common, perhaps other moons throughout the solar system have experienced similarly dramatic fates, leaving behind stories every bit as strange as the one being investigated here. When most people think about moons, they imagine simple companions quietly circling their planets through the darkness of space. The image feels peaceful and orderly. A planet travels around the sun, a moon travels around the planet. Relationship appears stable, almost timeless. Yet the deeper scientists explore the solar system, the more they discover that moons often lead surprisingly complicated lives. Far from being passive objects, many moons exist within dynamic systems shaped by constant gravitational interactions. They influence one another, alter one another's paths, and sometimes experience histories every bit as dramatic as those of the planets they accompany. The giant planets provide some of the most remarkable examples. Around Jupiter and Saturn, entire communities of moons move through space together. Some are large enough to qualify as worlds in their own right. Others are small and irregular. Collectively, they create complex gravitational environments where interactions unfold across immense stretches of time. In certain cases, moons become locked in orbital resonances. Their motions develop predictable relationships, creating patterns that repeat again and again. These arrangements can remain stable for long periods, yet they also demonstrate how deeply connected lunar systems can become. One moon influences another, that moon influences a third. Tiny effects accumulate. Over millions or billions of years, the consequences can be profound. The audience begins to realize that moons are not isolated travelers. They are participants in ongoing gravitational conversations that shape their futures in subtle and sometimes unexpected ways. Some histories become even stranger. Researchers studying certain moons have proposed that not all of them formed where they currently reside. Instead, some may have originated elsewhere before being captured by the gravity of a larger planet. Rather than being born within their present systems, they may be cosmic arrivals from distant regions. The implications are extraordinary. A moon visible today may have spent part of its existence wandering through entirely different environments before finding its current home. Other moons may represent fragments of something larger. Evidence suggests that collisions have shattered bodies throughout the solar system. In some cases, groups of smaller objects appear connected by a common origin. They may be remnants of worlds that no longer exist in their original form. This pattern feels increasingly familiar. Again and again, scientists encounter stories involving destruction, transformation, and survival. Worlds break apart. Worlds merge together. Objects change identities while preserving traces of their past. The audience begins viewing moons differently. They are no longer simple companions decorating planetary systems. They become survivors of ancient events, carrying histories that are often far more complicated than their current appearances suggest. Earth's moon now enters this broader context. For centuries, humanity treated it as a stable fixture in the sky. It appeared unique because it was the only moon people could easily observe in detail. Yet the more researchers learn about moons elsewhere, the harder it becomes to view Earth's moon as something fundamentally separate from the larger patterns of the solar system. Perhaps it too experienced a complicated history. Perhaps it endured collisions, migrations, and transformations similar to those observed elsewhere. Perhaps the clues preserved within its surface and interior are part of a story that remains only partially understood. This perspective does not prove the existence of a missing moon. What it does is make the idea feel less extraordinary. If other moons have been captured, altered, fragmented, or reshaped by dramatic events, why should Earth's moon be exempt from such possibilities? Why assume its history was simpler than the histories unfolding around Jupiter, Saturn, and other worlds? Mystery becomes easier to imagine because the solar system repeatedly demonstrates that unexpected things happen. Sometimes they happen often. By the end of this journey through distant lunar systems, the audience is left with a new understanding. The question is no longer whether strange things can happen to moons. The evidence suggests they can. The deeper question is whether Earth's missing moon represents an unusual exception, or whether it is simply another chapter in a much larger cosmic story, one that has been repeating itself throughout the solar system since the beginning. After examining ancient collisions, vanished worlds, and the strange histories of distant moons, a larger pattern begins to emerge. First, it is easy to miss. Human beings naturally focus on what survives. We look at planets and assume they have always existed in roughly their current forms. We see moons orbiting overhead and imagine a long, uninterrupted history stretching backward through time. Stability feels normal because it is what remains visible. Yet the universe tells a different story. Again and again, the evidence points toward a reality shaped not by permanence but by transformation. Worlds form, change, worlds disappear. The pattern repeats across the solar system and far beyond it. Appears solid and enduring is often the result of countless earlier events hidden beneath the surface of history. Every planet carries traces of older chapters. Every moon may contain fragments of stories that ended long ago. The audience is invited to step back and look at the mystery from a wider perspective. Mercury may bear the consequences of ancient impacts. Mars preserves evidence of a more active past. Asteroids drift through space as remnants of larger objects that no longer exist in their original forms. Even Earth's moon, once thought to be simple and familiar, now appears connected to possibilities far stranger than previously imagined. The same lesson emerges everywhere. Creation and destruction are not opposites. They are partners. Collision destroys one object while helping to create another. A merger erases identities while producing something new. Material does not simply vanish. More often it changes form, joins something larger, or becomes part of a different story. This realization leads directly to one of the most fascinating implications of the missing moon theory. Perhaps the second moon never truly disappeared. At first the statement seems contradictory. The entire mystery revolves around a world that vanished from Earth's sky. How can something be lost and still remain? The answer lies in the distinction between disappearance and destruction. If the companion moon slowly merged with the larger moon, much of its material would survive. Rocks that once belonged to an independent world could still exist. Minerals formed billions of years ago might remain embedded within the lunar crust. Entire regions of the moon may contain remnants of an object that no longer exists as a separate body. The lost moon may not be gone. It may simply be unrecognizable. This possibility reframes everything that came before. Instead of imagining a world erased from existence, the audience begins imagining a world absorbed into another. The moon visible tonight may contain pieces of a forgotten companion hidden within its structure. The mystery shifts from absence to presence. Suddenly, the question becomes much more profound. What does survival actually mean? Human intuition often associates survival with remaining unchanged, yet the universe repeatedly suggests otherwise. Stars transform, planets evolve, moons collide, entire systems rearrange themselves. Survival frequently occurs through adaptation, merger, and transformation rather than permanence. The moon may be another example. If the theory proves correct, then a vanished moon did not simply disappear into darkness. It became part of something larger. Its identity was lost, but its substance endured. That idea carries a strangely reflective quality. The cosmos is filled with endings that are not truly endings. Beneath apparent destruction often lies continuity. Beneath disappearance often lies transformation. For viewers listening beneath the quiet glow of the modern moon, the thought is difficult to ignore. Perhaps the second moon is not hidden somewhere in space. Perhaps it is hiding in plain sight. And yet, before accepting such a remarkable conclusion, an important challenge remains. Scientific mysteries are not solved through imagination alone. Intriguing evidence must withstand scrutiny. The next chapter therefore turns toward the strongest objections to the theory, exploring why many researchers remain skeptical despite the clues, the simulations, and the possibility that a lost world may still circle Earth every night. By this point in the story, the missing moon hypothesis may feel surprisingly convincing. The clues appear intriguing. Computer simulations produce compelling results. The moon's unusual structure seems capable of supporting a dramatic explanation. Piece by piece, the possibility of a vanished lunar companion begins to resemble a genuine solution to a long-standing mystery. And that is precisely the moment when science becomes cautious. The documentary now changes direction. Instead of asking why the theory might be correct, it asks why many scientists remain unconvinced. This shift is not a weakness in the investigation. In fact, it is one of the most important parts of the process. Scientific progress does not depend on belief. It depends on skepticism. Ideas become stronger only after surviving attempts to challenge them. The more extraordinary a claim becomes, the more carefully researchers examine it. A second moon orbiting Earth billions of years ago certainly qualifies as extraordinary. For that reason, many planetary scientists approach the theory with caution. They do not reject it outright. They simply argue that intriguing possibilities are not the same thing as demonstrated facts. The universe is filled with explanations that seem appealing at first glance, but ultimately prove incorrect when examined more closely. This perspective introduces an important question. What if the evidence supporting a lost moon can be explained in other ways? The possibility is not only reasonable, it is one of the central debates surrounding the mystery. Consider the moon's thick far-side crust, one of the most frequently discussed clues in the entire theory. Supporters of the merger hypothesis view it as potential evidence that material from a smaller companion accumulated on one hemisphere. The explanation is elegant and appealing, yet alternative interpretations exist. Some researchers argue that differences in cooling rates during the moon's earliest history may account for the same observation. Others suggest that uneven distributions of heat influenced how material solidified. Additional theories focus on internal geological processes that unfolded shortly after lunar formation. These explanations are often less dramatic. They do not involve vanished worlds or ancient collisions between moons. They possess an important advantage. They require fewer assumptions. In science, simpler explanations frequently receive serious consideration because they introduce fewer unknown variables. A theory that explains an observation without adding extra events or objects is often viewed as attractive, at least until evidence suggests otherwise. The audience now encounters one of the most fascinating realities of scientific investigation. The same evidence can support multiple stories. A thick crust is not a narrative by itself, it is a clue. Researchers must decide what that clue means. One scientist may see evidence of a merger, another may see evidence of ancient thermal processes. Both are examining the same moon. The disagreement emerges from interpretation. This realization changes how the mystery is understood. Earlier chapters may have created the impression that evidence steadily accumulates in favor of the missing moon theory. Now a more nuanced picture emerges. Evidence does not automatically point in a single direction. Sometimes it points towards several possibilities simultaneously. The audience is invited to appreciate uncertainty rather than fear it. In popular culture, mysteries often end with a clear answer. Scientific mysteries rarely behave that way. They grow more complex as new information arrives. Every discovery resolves some questions while creating others. The missing moon hypothesis remains intriguing because it addresses several observations at once. Yet those observations are not exclusively its own. Competing explanations continue to challenge it. Far from weakening the story, this tension makes it more compelling. The mystery survives because the evidence has not settled the debate. And that means the investigation must continue. If scientists remain divided about the meaning of the clues hidden within the moon, the next logical step is to examine the alternative explanations directly. By understanding those competing ideas, can the true strength and the true weakness of the two-moon hypothesis be fully appreciated? Once a mystery gains momentum, there is a natural temptation to search for a single answer. Missing moon hypothesis offers exactly that kind of appeal. It provides a dramatic narrative capable of explaining several unusual features at once. Vanished companion moon feels memorable. It transforms geological details into the remnants of an ancient cosmic event. Yet science rarely settles for the most captivating story. Instead, it asks a more difficult question: what other explanations are possible? The answer leads into a landscape of competing ideas, where multiple theories attempt to explain the moon's unusual characteristics without requiring a second moon at all. One of the most widely discussed alternatives begins during the moon's earliest history. Billions of years ago, the newly formed moon orbited much closer to Earth than it does today. The young Earth was still extremely hot, radiating enormous amounts of energy into space. Some researchers suggest that this intense heat may have influenced the side of the moon facing Earth. The idea is surprisingly simple. If one hemisphere remained exposed to a warmer environment while the opposite side cooled more rapidly, differences in crust formation might naturally emerge. The far side could develop a thicker crust without requiring any collision with a companion moon. The theory explains certain observations quite well. Yet questions remain. While temperature differences may account for some asymmetries, they do not necessarily explain every feature scientists observe. Certain details continue to challenge researchers, leaving room for additional interpretations. Other investigators focus on volcanic activity. The moon was not always the quiet world visible today. During its early history, molten material moved beneath the surface. Vast volcanic events reshaped entire regions. Some scientists propose that these processes may have contributed to differences between the near side and far side. Again, the explanation appears plausible. Again, it leaves certain puzzles unresolved. Then there are impact-based theories. The solar system's youth was extraordinarily violent. Massive collisions occurred regularly. Some researchers suggest that one or more ancient impacts may have altered the moon's structure in ways still visible today. Hidden beneath the surface could be evidence of events powerful enough to redistribute material across entire hemispheres. These ideas solve some problems while creating others. That pattern repeats throughout lunar science. Theory explains crust thickness but struggles with topographical details. Another accounts for geological patterns but leaves unanswered questions about material distribution. Third matches certain observations beautifully while failing to explain others. The audience begins to recognize something important. Scientific mysteries are rarely contests between one perfect explanation and several obviously flawed alternatives. More often, they involve multiple imperfect explanations competing for credibility. Each captures part of the truth. None fully captures all of it. This realization introduces one of the most fascinating twists in the story. The goal of science is not always to discover certainty immediately. Sometimes the goal is to gradually eliminate possibilities while improving understanding. Researchers compare models, test assumptions, and search for evidence capable of distinguishing between competing ideas. Progress often occurs through refinement rather than revelation. The moon's asymmetrical appearance remains a powerful example. Decades of investigation have produced numerous explanations, yet none has completely ended the debate. The mystery survives precisely because every theory leaves something unexplained, including the missing moon hypothesis. This balance of uncertainty creates a peculiar kind of tension. The audience is no longer choosing between a dramatic story and a dull alternative. Instead, they are confronting several plausible possibilities, each supported by evidence, each facing challenges. The truth may ultimately involve factors from more than one explanation. It may be simpler than expected, may be more complicated than anyone currently imagines. For now, the moon continues withholding its final answer, and that uncertainty reveals another challenge lurking beneath the entire investigation. Scientists are attempting to reconstruct events that occurred billions of years ago. Evidence is incomplete. Time has erased countless details. Even the best theories must contend with the enormous difficulty of understanding a past so distant that almost none of its original records survive. There is an opponent present throughout this entire investigation, one far more powerful than any competing scientific theory. It is not gravity, it is not geology, it is time. More specifically, it is deep time. The immense span of years separating the modern world from the events researchers are trying to understand. Possible existence of a second moon belongs to an era more than 4 billion years in the past. That number is so vast that the human mind struggles to grasp its meaning. Civilization occupies only a tiny fraction of it. Recorded history occupies even less. The mystery reaches back to a period older than forests, older than dinosaurs, older than complex life itself. That distance creates extraordinary challenges. Imagine attempting to solve a crime after billions of years have passed. Witnesses are gone, records have vanished, most of the physical evidence has been altered, buried, or destroyed. Remains are fragments, small clues separated from their original context by almost unimaginable stretches of time. Planetary science often operates under exactly those conditions. The audience is invited to consider what happens to evidence over immense timescales. Impacts strike planetary surfaces and create craters. Later impacts strike those same regions, partially erasing older features. Geological processes reshape landscapes. Material moves, structures change. Even on the Moon, where history survives better than on Earth, preservation is not perfect. The lunar surface has experienced billions of years of bombardment. Countless impacts have modified earlier impacts. Ancient features have been altered, buried beneath debris, or obscured by subsequent events. The Moon retains extraordinary records of the past, yet those records are incomplete. Presents an even greater challenge. The oceans, erosion, and tectonic activity continuously recycle the planet's surface. Much of Earth's earliest history has disappeared entirely. Many rocks formed during the age of the hypothetical second moon no longer exist. Others survive only as altered remnants of what they once were. This means researchers are investigating events older than nearly all surviving landscapes on Earth. The realization is humbling. Scientists are not simply trying to explain a mystery. They are attempting to reconstruct an episode from a world so ancient that almost every direct record has been lost. The audience begins to appreciate why debates surrounding the missing moon remain unresolved. It is not necessarily because researchers disagree about basic facts. Often they are working with evidence that is incomplete by its very nature. This leads to one of the most important revelations in the documentary. The absence of evidence is not necessarily evidence of absence. A second moon may have existed and left only faint traces behind. Billions of years of history could easily reduce dramatic events to subtle clues. In that scenario, the lack of definitive proof would be exactly what scientists should expect. Yet the opposite possibility is equally important. The absence of decisive evidence may also mean the theory is incorrect. This balance lies at the heart of the mystery. Researchers must navigate between two possibilities that can appear remarkably similar. One involves a real event hidden by time. The other involves an event that never happened at all. Distinguishing between them is extraordinarily difficult when most of the original evidence has vanished. The audience is left with a deeper appreciation for the nature of scientific uncertainty. Some mysteries survive because humans lack sufficient information. Others survive because time itself has become an active participant in the story, slowly concealing clues across billions of years. Missing Moon may belong to that second category. Whether the theory ultimately proves correct or incorrect, the investigation reveals something profound about humanity's search for knowledge. There are questions so ancient that even the universe seems reluctant to surrender their answers. Yet researchers continue searching, not because certainty is guaranteed, but because the clues that remain are too intriguing to ignore. And after confronting the limitations imposed by deep time, the story can finally explore a different kind of question. Not what happened billions of years ago, but what the world might look like today if two moons had survived and continued sharing Earth's sky until the present. For much of this journey, the focus has remained on evidence. Researchers examined lunar geology. Simulations recreated ancient collisions. Competing theories challenged one another. Every step sought to answer a single question. Did Earth once possess a second moon? Now the story takes a different path. Instead of asking what happened, it asks what might have happened. Imagine for a moment that the smaller companion moon never collided with the larger moon. Imagine that it survived. Through billions of years of planetary history, through the rise of oceans, the emergence of life, and the appearance of humanity, both moons remained in the sky. The modern world would immediately feel different. Step outside on a clear evening and look upward. Familiar moon still hangs above the horizon, bright and reassuring. Yet nearby, another lunar world travels through the darkness. Smaller, perhaps dimmer, but unmistakably present. It follows its own path through the heavens, creating patterns that humanity would never consider unusual because they had always been there. Some nights both moons rise together, other nights only one appears. Occasionally they drift close enough to create extraordinary spectacles visible from Earth. Their combined light transforms the darkness. Shadows become more complex. Familiar landscapes acquire a subtly different appearance beneath the glow of two celestial companions. The audience is invited to imagine how ordinary such sights would seem to people born into that world. Children would grow up seeing two moons. Poets would write about two moons. Travelers would navigate by two moons. No one would find the arrangement strange, because it would simply be reality. Consequences would extend far beyond astronomy. Throughout history, human beings have looked toward the sky for meaning. The movements of celestial objects shaped calendars, guided agriculture, inspired myths, and influenced entire belief systems. A second moon would almost certainly have become woven into those traditions. Ancient cultures might tell stories explaining the relationship between the two lunar worlds. Some civilizations could view them as rivals. Others might imagine them as companions. Religious symbolism would evolve differently. Legends would emerge around their changing positions. Entire traditions could develop around moments when both appeared together in the night sky. Even language itself might change. Concepts associated with the moon would require new distinctions. The sky would contain not one dominant lunar presence, but two, each demanding interpretation and meaning. The audience begins to realize that a seemingly small difference in the heavens could reshape countless aspects of human culture. Art would change. Architecture might change. Navigation and timekeeping could develop along different paths. Stories passed from generation to generation would reflect a world illuminated by two celestial lights rather than one. The emotional impact of this realization is surprisingly powerful. Human history often feels inevitable when viewed in hindsight. Events appear fixed. Cultures evolve as though no alternative paths ever existed. Yet this exercise reveals how sensitive civilization can be to its environment. Change the sky, and you may change much more than the sky. A second moon would become part of humanity's identity. Every culture would inherit a relationship with both worlds. Every civilization would build its understanding of the universe around their presence. And yet, despite all these differences, Earth would still be recognizable. People would still stand beneath the stars. They would still wonder about their place in the cosmos. Curiosity would remain. Mystery would remain. Only the backdrop would change. The thought leaves the audience with a new appreciation for the familiar moon hanging overhead tonight. Its solitary presence may not simply be a feature of the modern world. It may represent the outcome of an ancient history that unfolded long before humanity arrived. Appearances are only one part of the story. If two moons survived into the present, their influence would extend beyond culture and imagination. Their gravitational pull would continue affecting the planet itself, subtly reshaping the oceans, coastlines, and environments upon which life depends. A second moon would not merely change the appearance of the night sky. Its influence would reach downward, touching the oceans, shaping coastlines, and quietly affecting environments where countless forms of life evolved. While myths, art, and human culture might eventually reflect the presence of two moons, the physical world would begin responding to them long before humanity ever appeared. The story starts with water. Even today, Earth's oceans respond continuously to the gravitational pull of the moon. Tides rise and fall with remarkable regularity, creating rhythms that influence coastlines across the globe. Entire ecosystems depend upon those cycles. Shorelines flood and retreat. Nutrients move through marine environments. Species adapt to predictable changes in water levels. Now imagine adding a second moon to the system. The result would not necessarily be stronger tides all the time. The reality would likely be far more complicated. At certain moments, the gravitational influence of both moons might combine. Pulls would reinforce one another, creating larger tidal ranges than those typically experienced today. Coastal waters could advance farther inland. Certain regions might experience more dramatic shifts between high and low tide. At other times, the opposite might occur. Depending on their positions, the moons could partially counteract one another's influence. Tidal patterns might weaken. Familiar rhythm of the oceans would become more complex, shaped by interactions between two constantly moving celestial bodies rather than one. The audience is invited to picture ancient coastlines responding to these changing patterns. Shallow bays repeatedly fill and empty. Mudflats appear and disappear. Coastal pools expand, shrink, and reconnect with the sea in cycles unfamiliar to the modern world. None of these changes seem extraordinary when viewed over a single day. Planetary history is rarely shaped by single days. It is shaped by repetition. Process repeated millions of times can transform entire environments. This is where the alternate Earth begins to diverge from the one humanity knows. Marine habitats evolve within specific conditions. Some species thrive in stable environments. Others benefit from constant change. If tidal behavior differs over geological timescales, ecosystems may follow different developmental paths. And coastal habitats could expand. Others might become less common. Patterns of nutrient circulation may shift. Sediment movement might change. Regions favorable to particular forms of life could emerge in some places while disappearing in others. The documentary carefully avoids claiming that a second moon would completely rewrite biological history. Such conclusions reach far beyond available evidence. Yet researchers understand that environmental conditions matter. Small differences, repeated across millions of years, can influence ecological development in meaningful ways. Realization forms the heart of the mystery. The audience begins to appreciate how interconnected planetary systems truly are. Change in the sky influences gravity. Gravity affects water. Water shapes environments. Environments influence the opportunities available to living organisms. The chain stretches from celestial mechanics to coastal ecosystems. What initially appeared to be a question about a missing moon becomes a question about the relationships connecting every part of a world. A fascinating aspect is how subtle the process appears. No dramatic catastrophe is required. No sudden transformation reshapes the planet overnight. Instead, tiny differences accumulate gradually. Each tidal cycle contributes a small effect. Millions of years, those effects add together, producing outcomes that may become significant despite being nearly invisible from one generation to the next. The audience is left contemplating a powerful possibility. A second moon might not have changed life through dramatic intervention. It might have influenced the conditions under which life evolved by quietly altering the environments where countless species lived and adapted. Such influence would be difficult to detect after billions of years, yet it illustrates an important truth about planetary history. The universe often operates through connections that are easy to overlook until someone follows them far enough. And the connections do not end with oceans. The same gravitational forces capable of shaping tides also influence the long-term behavior of entire planets, raising an even larger question about how two moons might have affected Earth's stability, climate, and balance through the vast stretches of time that followed. The influence of a second moon may extend far beyond oceans and coastlines. To understand why, it is necessary to look beyond Earth's surface and consider something less visible but equally important: the orientation of the planet itself. At this very moment, Earth spins on a tilted axis. Tilt determines how sunlight is distributed across the globe, shaping seasons, climate patterns, and environmental conditions. It influences where ice accumulates, where deserts form, and how energy moves through the atmosphere and oceans. Most people never think about it. The tilt simply exists, quietly governing the rhythm of the world. Yet scientists have long understood that the moon plays an important role in maintaining that balance. Its gravitational influence helps moderate fluctuations in Earth's axial tilt, reducing the likelihood of extreme variations over long periods of time. Without that stabilizing effect, the story of Earth might look very different. Computer models suggest that planets lacking a substantial moon can experience larger changes in orientation. For millions of years, such variations may alter climate systems dramatically. Regions that once received moderate amounts of sunlight could become far hotter or colder. Environmental conditions might shift in ways difficult to imagine from a modern perspective. The moon, in a sense, acts as a quiet guardian of stability. Now the mystery introduces a fascinating complication. What happens if there are two moons instead of one? At first glance, the answer appears straightforward. More moons should mean more stability. More gravitational influence should strengthen the balancing effect. Yet the universe often proves more complicated than intuition suggests. Researchers investigating multiple moon systems have discovered that outcomes depend heavily on the details. The size of the moons matters, their distances matter, their orbital relationships matter. Even tiny differences can influence how the system evolves across immense spans of time. In some scenarios, a second moon appears to contribute additional stability. The combined gravitational effects help maintain a relatively consistent orientation for the planet. Such arrangements could potentially create long periods of environmental predictability. Other simulations tell a different story. Additional moons introduce additional interactions. Those interactions can increase complexity rather than reduce it. Instead of strengthening stability, they may create subtle instabilities that accumulate over time. The resulting planetary behavior becomes more difficult to predict. The audience is once again confronted with uncertainty. There is no single answer. The influence of a second moon depends upon circumstances hidden deep within the past. The exact arrangement of such a system, if it ever existed, remains unknown. Researchers can explore possibilities, but certainty remains elusive. Then comes the most intriguing realization of all. It may have possessed many possible futures. The modern world often feels inevitable because it is the only version humanity has ever experienced. Seasons arrive according to familiar patterns. Climate systems operate within recognizable limits. Planet appears balanced. That balance may have depended on countless factors unfolding during the solar system's earliest history. A slightly different orbit, a different collision, a surviving second moon, tiny changes during those distant epochs could potentially have guided Earth along alternative paths. Necessarily uninhabitable paths, simply different ones. The audience begins to see the planet through a new lens. It becomes less like a predetermined destination and more like the outcome of an extraordinarily complex chain of events. Every stage influenced the next. Every variable mattered. The story of a possible second moon fits naturally within that perspective. Perhaps it existed and influenced the balance of the young Earth before disappearing. Perhaps it never existed at all. Either way, the investigation reveals something profound about planetary history. Worlds are shaped by interactions so subtle and ancient that their effects can echo across billions of years. The modern Earth may represent only one outcome among many possibilities hidden within the chaos of the early solar system. And while speculation can illuminate those possibilities, evidence remains essential. The mystery therefore returns to where science is strongest: observation, measurement, and investigation. Future lunar missions, new instruments, and increasingly sophisticated research may finally provide clues capable of distinguishing between competing theories and bringing humanity closer to understanding whether a second moon truly once shared Earth's sky. Much of this story, the investigation has focused on events buried deep within the past: ancient collisions, lost worlds, gravitational encounters that may have unfolded more than 4 billion years ago. The mystery often feels distant, as though it belongs entirely to an era forever beyond human reach. Yet the search for answers is not confined to the past. It is happening right now. While the moon continues its familiar journey across the night sky, a new generation of explorers is returning humanity's attention to our nearest celestial neighbor. Robotic spacecraft circle overhead, orbiters gather data, engineers design future missions. Plans for long-term lunar exploration are moving from imagination toward reality. The audience is invited to view the moon not as a completed chapter of scientific history, but as an active investigation still unfolding. This is one of the most exciting aspects of the mystery. The final answers may not have been discovered yet. Earlier generations of lunar explorers achieved extraordinary milestones. They mapped the surface, landed spacecraft, and brought samples back to Earth. Those achievements transformed human understanding of the moon. Yet compared to modern technology, the tools available at the time were limited. Today's instruments operate on an entirely different level. Orbiters can measure tiny variations in the moon's gravitational field. Sensitive instruments map crust thickness with remarkable precision. Researchers analyze mineral composition across vast regions of the lunar surface. Subsurface structures hidden beneath ancient terrain can be studied in ways impossible only decades ago. Every new measurement adds another piece to the puzzle. The audience begins to appreciate how much information remains hidden within the moon. Its visible surface tells only part of the story. Beneath that surface lie clues capable of revealing details about formation, evolution, and perhaps even the existence of a long-lost companion moon. Scientists are particularly interested in features that might distinguish between competing theories. How thick is the crust in specific regions? How is material distributed beneath the surface? Patterns emerge when gravitational data is compared with geological observations. Each question helps narrow the range of possible explanations. Then comes an important realization. Researchers are not necessarily trying to prove the missing moon hypothesis. This distinction matters. Science functions best when investigators follow evidence rather than conclusions. The goal is not to confirm a favorite theory. The goal is to discover which explanation best matches reality. New lunar missions therefore collect information capable of testing many ideas at once. The same data might support one theory, challenge another, or reveal an entirely unexpected possibility. That is what makes the investigation so dynamic. The audience is reminded that scientific mysteries are rarely solved through a single dramatic discovery. More often, progress emerges gradually as evidence accumulates. Measurements improve. Models become more sophisticated. Questions once considered impossible begin yielding partial answers. The mystery of the missing moon exists within that process. Every new mission has the potential to uncover information relevant to the debate. A subtle structural pattern might support one explanation. An unexpected distribution of material could challenge another. Even negative results provide valuable insight by eliminating possibilities. Far from reaching its conclusion, the investigation may still be in its early stages. That thought creates a renewed sense of wonder. The clues required to solve the mystery may already exist somewhere on the moon, waiting to be recognized. Perhaps future missions will uncover entirely new evidence hidden beneath ancient landscapes untouched for billions of years. The search continues because the moon continues offering secrets, and as increasingly detailed information arrives, another challenge becomes just as important as collecting the data itself. Scientists must learn how to interpret what they find. Massive quantities of measurements are valuable only when transformed into understanding. To accomplish that task, researchers are turning to some of the most powerful analytical tools humanity has ever created, using advanced simulations and computational models to recreate ancient events and test whether the stories hidden within lunar data truly match the history of the solar system. For centuries, understanding the distant past depended largely upon observation. Scientists studied rocks, examined landscapes, and pointed telescopes toward the sky. Clues were gathered piece by piece, each discovery adding another fragment to humanity's understanding of the universe. Yet certain mysteries remained frustratingly difficult to investigate because no direct record survived. Possible existence of a second moon belongs to that category. No witness observed it, no image captured it. If it existed, it vanished billions of years before the first human ever wondered about the night sky. And yet, modern science possesses an extraordinary tool capable of reaching into those lost ages: computation. The audience now enters a world where ancient history is reconstructed not through excavation alone, but through mathematics, physics, and machines powerful enough to simulate entire planetary systems. At first glance, the idea seems almost impossible. How can a computer investigate events that occurred billions of years ago? The answer lies in something surprisingly simple. The laws of physics operating today are the same laws that governed the early solar system. Gravity still behaves according to measurable rules. Matter still responds to energy in predictable ways. Collisions, orbits, and motion follow principles that can be described mathematically. If those rules are understood, researchers can build virtual worlds and watch them evolve. This process has transformed planetary science. Scientists create digital versions of the early solar system, populate them with young planets, clouds of debris, and newly formed moons. They allow gravity to begin its work. Time accelerates. Millions of years pass inside a simulation in moments. Results are often astonishing. Virtual moons appear from debris fields. Orbits shift and evolve. Worlds migrate through space. Some remain stable, others collide. Entire histories unfold within environments that exist only inside a computer. The audience is invited to imagine thousands of alternate solar systems being tested one after another. A small adjustment is made, the simulation runs again. Another variable changes, the simulation runs once more. Most outcomes fail to resemble reality. Some generate structures unlike anything observed, others produce systems too unstable to survive. Those failures are valuable because they eliminate possibilities. Gradually, a narrower set of scenarios begins to emerge. Researchers compare simulated outcomes against actual observations gathered from the moon. Does the crust resemble reality? Do gravitational patterns match measured data? Does the resulting structure resemble the world orbiting Earth today? Each successful comparison strengthens confidence in a particular possibility. This is where the mystery becomes especially fascinating. Future breakthroughs may not arrive solely from telescopes or spacecraft. Some may emerge from simulations capable of testing thousands of histories that never actually happened. By comparing those virtual worlds against reality, scientists can identify which stories remain plausible and which must be discarded. In a sense, computers become laboratories for lost time. They allow researchers to explore possibilities inaccessible through direct observation. Events that vanished billions of years ago can be reconstructed, challenged, and refined. The missing moon theory benefits enormously from this approach. Certain simulations naturally generate companion moons. Some maintain those moons for millions of years before producing mergers remarkably similar to those proposed by researchers. Others reveal entirely different pathways that explain lunar features without requiring a second moon at all. The audience begins to understand that the investigation resembles an enormous puzzle. Its pieces are scattered across multiple fields of knowledge. Geology contributes clues hidden within lunar rocks. Astronomy reveals orbital behavior. Physics provides the rules governing motion and collision. Mathematics connects everything together. No single discipline can solve the mystery alone. Only when all the pieces are assembled does a clearer picture begin to emerge, and with every improvement in computing power, that picture becomes sharper. Yet even the most sophisticated simulation ultimately serves a larger purpose. The mystery of the missing moon is not merely about understanding a vanished world. It is about understanding how worlds form, evolve, and survive. As evidence accumulates and models improve, the investigation approaches an even deeper question, one that extends beyond the moon itself and touches upon humanity's place within a universe shaped by change, uncertainty, and the endless transformation of worlds. At first glance, the story of a missing moon appears to be a very specific mystery. It concerns one planet, one moon, and a possible companion that may have existed billions of years ago. The investigation revolves around lunar geology, orbital dynamics, and ancient collisions. Everything seems focused on a single question hidden within the history of the Earth-Moon system. As the journey progresses, something larger begins to emerge. The mystery is no longer only about the moon. It is about how knowledge itself advances. Throughout history, many of humanity's greatest discoveries began with details that seemed insignificant. A small inconsistency, an unexpected observation, pattern that refused to fit comfortably within existing explanations. Most anomalies eventually disappear when new information arrives. A few refuse to go away. Those are often the ones that change everything. The audience is invited to look back at the clues that started this investigation. The unusually thick crust on the moon's far side, geological asymmetries that seemed difficult to explain, computer simulations producing unexpected results. None of these observations proved the existence of a second moon. What they did was raise questions, and questions are powerful. Scientific revolutions rarely begin with certainty. They begin when someone notices something that does not behave as expected. Curiosity follows. New investigations begin. Assumptions are challenged. Slowly, understanding expands. The missing moon hypothesis emerged through exactly that process. Researchers were not searching for a lost world. They were attempting to explain observations. Possibility of a companion moon appeared because the evidence allowed it to appear. Whether the theory ultimately proves correct is almost secondary to the lesson it provides. The universe still contains surprises, even in places that seem familiar. The moon has accompanied humanity throughout recorded history. It has guided travelers, inspired artists, shaped calendars, and influenced countless cultures. Generations have looked toward it with a sense of familiarity that few celestial objects can match. Yet familiarity can be deceptive. People often assume they understand what they see every day. The moon feels known because it is always present. It feels simple because it appears unchanged. Scientific investigation repeatedly reveals hidden layers beneath that appearance. The audience begins to appreciate a profound irony. The object closest to Earth may still contain mysteries capable of challenging established ideas. The moon is not a distant galaxy beyond observation. It is not an inaccessible world hidden at the edge of the solar system. It hangs above us every month. Still, fundamental questions remain. How exactly did it form? Why does its structure differ so dramatically from one hemisphere to the other? What events shaped its earliest history? Could another moon once have shared its orbit? These questions survive despite centuries of observation and decades of intensive scientific study. Realization leads to one of the most powerful revelations in the documentary. Humanity has walked on the moon. Spacecraft have mapped its surface. Samples have been carried back to Earth and examined in laboratories. and yet the story remains unfinished. The audience is left with a renewed sense of wonder. Knowledge has advanced enormously, but every answer seems to reveal additional layers of complexity. Closer researchers look, the more they discover that certainty remains elusive. The moon that appears so familiar may still be hiding extraordinary secrets. Perhaps the missing moon theory will eventually be confirmed. Perhaps it will be replaced by a different explanation. Perhaps the truth will combine elements of multiple ideas not yet fully understood. Whatever the outcome, the investigation demonstrates something larger than any individual theory. Mysteries do not survive because the universe lacks answers. They survive because discovering those answers requires patience, imagination, and the willingness to question what appears obvious. And that brings the story to its final stage. The clues have been gathered, the competing theories have been explored, possibilities have been examined from every angle. Now the remaining task is to bring everything together and confront the central question one last time. Earth's lost moon merely an intriguing idea, a genuine possibility, or a forgotten reality that has been hiding in plain sight all along? After traveling through billions of years of history, examining evidence, questioning assumptions, and exploring competing explanations, the investigation arrives at a familiar moment in every great mystery. Pieces must be assembled. Not because certainty has been achieved, but because enough clues exist to attempt a reconstruction. The audience is invited to imagine the most plausible version of events suggested by the evidence gathered so far. It is not a proven history. It is a possible history. A narrative built from geology, physics, simulations, and observations scattered across immense stretches of time. The story begins in violence. More than 4 billion years ago, a colossal impact reshapes the young Earth. Planetary body crashes into the growing world, releasing unimaginable energy. Rock vaporizes. Debris is launched into orbit. A glowing ring of material surrounds the planet. From destruction comes creation. Fragments collide and merge. Gravity gathers scattered material into larger structures. Slowly, new worlds emerge from the aftermath. One becomes the moon familiar to humanity today. Perhaps it was not alone. Some simulations suggest that a second lunar body may have formed from the same debris field. Smaller and less massive, it follows a different path around Earth. The larger moon dominates the system, while the companion occupies a more delicate gravitational arrangement. Time both survive. Millions of years pass. Earth changes dramatically beneath them. Oceans begin forming. The young planet cools. The solar system gradually becomes less chaotic than it was during its earliest epochs. Above this evolving world, two moons continue their silent journey. The audience now begins recognizing how the various clues discussed throughout the documentary fit together. Possibility of multiple lunar bodies emerges from formation models. The long-term survival of a companion moon appears plausible within certain orbital scenarios. The gradual influence of gravity explains how stability might eventually weaken. The thick far-side crust offers a potential geological fingerprint of a later merger. None of these pieces prove the theory independently. Together, however, they begin forming a coherent picture. This is where the missing moon hypothesis becomes especially compelling. Its greatest strength is not that it explains a single mystery. Many theories can explain individual observations. What attracts scientific interest is the possibility that one event may account for several otherwise disconnected puzzles at the same time. A companion moon could potentially explain aspects of lunar structure. It could align with specific simulation outcomes. It could offer a mechanism for the unusual distribution of crustal material. It could connect multiple observations into a single narrative framework. The audience realizes why researchers continue discussing the idea despite ongoing skepticism. The theory survives because it possesses explanatory power. It links clues that might otherwise remain isolated. Yet an important distinction remains. A compelling explanation is not necessarily the correct explanation. Reconstruction still contains gaps. Scientists do not know every detail of the early Earth-Moon system. Important variables remain uncertain. Alternative theories continue competing for attention. New discoveries could strengthen the missing moon hypothesis, weaken it, or replace it entirely. Uncertainty creates a fascinating tension. The evidence feels persuasive enough to imagine the story unfolding. At the same time, enough unanswered questions remain to prevent complete confidence. The audience occupies the same position as the researchers themselves, suspended between possibility and proof. This balance is characteristic of scientific frontiers. The most interesting mysteries rarely offer simple answers. Instead, they present patterns, probabilities, and competing interpretations. Progress occurs gradually as evidence accumulates and understanding improves. For now, the missing moon remains exactly that kind of mystery. A plausible history has emerged from the clues. A world may have formed alongside the moon. It may have survived for millions of years. It may have influenced Earth before gradually moving toward its fate. And if that reconstruction is even partially correct, the story now approaches its most dramatic moment. Every clue, every simulation, and every possibility ultimately points toward a single event, the encounter that may have erased an entire world while leaving behind only the faintest traces of its existence. Every mystery eventually arrives at the moment everything depends upon. For the missing moon hypothesis, that moment is not the formation of a companion world. It is not the long period during which two moons may have shared Earth's sky. It is the ending, the disappearance. After millions of years of existence, the hypothetical companion moon approaches the final chapter of its story. The audience is invited to slow down and imagine the scene. The young Earth turns beneath the darkness. Oceans move across its surface. The larger moon continues its familiar orbit. Nearby, the smaller companion follows a path that has been gradually changing for ages. Nothing dramatic happens from one orbit to the next. That is what makes the story so unusual. Popular images of cosmic destruction often focus on sudden violence. Worlds explode. Massive impacts fill space with debris. Catastrophe arrives in an instant. Yet some of the most significant events in planetary history unfold with extraordinary patience. The fate of the companion moon may have begun long before the collision itself. Tiny gravitational influences accumulated over immense stretches of time. Small changes altered the moon's position. The delicate balance that once maintained separation slowly weakened. Orbit after orbit, the companion drifted toward a future that neither world could avoid. Process was almost invisible. Had an observer existed, the changes would have seemed insignificant. A slight adjustment here, a subtle shift there, nothing dramatic enough to inspire alarm. Yet gravity never stopped working. And eventually, the distance between the two moons became small enough that a collision could no longer be avoided. This is where the story diverges from expectation. Many people imagine two moons meeting in a spectacular explosion. It is a natural assumption. After all, the solar system contains countless examples of violent impacts. Craters, shattered bodies, scattered debris testify to the destructive power of high-speed collisions. Certain models suggest something different. The companion moon may have approached relatively slowly by cosmic standards. Instead of striking with overwhelming velocity, it could have merged with the larger moon in a far gentler encounter. The event remained enormous beyond human comprehension, yet compared with many planetary impacts, it may have been surprisingly subdued. Consequences were profound. An entire world lost its independence. The smaller moon ceased to exist as a separate object. Its identity vanished. Its orbit ended. Its long journey around Earth came to a close, and yet, according to the theory, much of its material survived. Rather than being blasted into space, rock from the companion moon may have spread across one hemisphere of the larger moon. Layer upon layer accumulated. Ancient crust merged with ancient crust. Two worlds became one. The audience now encounters the most emotionally resonant aspect of the mystery. The lost moon may not have been destroyed in the way people normally imagine destruction. It may have been absorbed, transformed. Its existence continued but in a different form. This realization gives the story an almost poetic quality. Throughout the universe, endings and beginnings often overlap. Stars die and create the elements needed for new stars. Collisions erase worlds while helping shape others. Matter changes identity without truly disappearing. Possible fate of the companion moon follows that pattern. Its name, if it ever had one, was lost. Its separate existence ended. Yet pieces of it may remain. The audience is invited to picture the modern moon hanging above Earth tonight. It appears solitary and complete. Generations have looked upon it without suspecting that part of its structure may belong to another world entirely. If the theory is correct, the moon visible today is not merely a survivor, it is a merger, a monument to an ancient encounter hidden beneath billions of years of history. And perhaps that is the most remarkable possibility of all. A moon may have disappeared without truly being destroyed. Its story ended, yet its material endured, which raises an even deeper question. If the mystery of the missing moon is not only about astronomy, but about transformation, survival, and change, then why does this story matter so much in the first place? At first glance, the mystery of a missing moon may seem strangely specific. Possible companion moon formed billions of years ago. It may have orbited Earth for millions of years before merging with the moon visible today. Researchers continue debating the evidence. Simulations test competing possibilities. Geological clues remain open to interpretation. It is an interesting puzzle, but why does it matter? Why do scientists devote years, sometimes entire careers, to investigating an event that may have occurred so long ago that almost no direct evidence survives? The answer begins with a simple realization. Understanding the moon means understanding Earth. The two worlds have never existed independently. Their histories are intertwined from the very beginning. The moon influences tides, stabilizes Earth's orientation, and preserves records from an era that our own planet has largely forgotten. Every major discovery about lunar history reveals something about the conditions under which Earth evolved. The audience is invited to look beyond the moon itself. The investigation is not really about one object in the sky. It is about origins. The moment scientists ask whether Earth once possessed two moons, they are also asking broader questions. How do worlds form? What happens after catastrophic collisions? How stable are planetary systems over immense stretches of time? How often do celestial bodies merge, disappear, or transform into something new? These questions extend far beyond the Earth-Moon system. Modern astronomy has revealed a universe crowded with planets. Thousands have already been discovered orbiting distant stars. Many possess configurations unlike anything found in our solar system. Some worlds travel through extreme environments. Others occupy complex systems shaped by multiple gravitational influences. Researchers want to understand how such systems evolve. The missing moon mystery contributes to that effort. Every clue about lunar history improves understanding of planetary dynamics. Every simulation provides insight into how worlds interact. Every competing theory helps refine the models scientists use when studying planets beyond our own. The audience begins to see that the investigation functions on multiple levels at once. On one level, it concerns a possible second moon. On another, it concerns the behavior of planetary systems throughout the cosmos. The mystery therefore becomes a window into a much larger story. Then comes one of the most important revelations in the documentary. The missing moon theory is not ultimately about a vanished object, it is about change. Human beings often view the universe as more stable than it truly is. Planets appear permanent. Moons seem eternal. Familiar objects in the sky create the impression that they have always existed in their present forms. Yet the evidence repeatedly suggests otherwise. Worlds evolve, orbits shift, collisions reshape entire systems. Objects that appear ancient and unchanged may actually be survivors of extraordinary histories. The moon itself may be an example. If the missing moon theory contains even part of the truth, then the object hanging above Earth tonight is not simply a solitary world. It is the product of transformation. Its present form would reflect events so ancient and dramatic that they almost sound fictional, and yet they may have happened. That possibility fills the story with a sense of awe. Humanity lives on a planet shaped by processes operating across billions of years. Oceans, continents, climates, and even the sky overhead may carry the consequences of events that occurred long before life emerged. The universe does not need mythology to be astonishing. Reality is often extraordinary enough on its own. The audience is left with a new perspective. The mystery matters because it reveals how much remains hidden beneath familiar appearances. Moon can conceal the memory of another moon. A stable world can emerge from chaos. An object that seems permanent can turn out to be the survivor of countless unlikely events. Perhaps that is the deepest lesson of all. The story of a missing moon is ultimately the story of how worlds endure by changing. With that realization, the investigation reaches its final stage. The evidence has been explored. Possibilities have been weighed. Now the mystery can be viewed from its widest perspective, one final time, beneath the familiar glow of the moon itself. After exploring ancient collisions, vanished worlds, competing theories, and billions of years of planetary history, the story arrives where it began. The moon, it hangs above Earth tonight exactly as it has for countless generations. Pale light spills across oceans, deserts, forests, and cities. People glance upward and immediately recognize it. Explanation is necessary, no introduction is required. The moon is familiar. Perhaps that is why its mysteries are so easy to overlook. Throughout human history, few objects have occupied such an important place in daily life. Long before telescopes existed, people measured time through its changing phases. Travelers used it to navigate unfamiliar landscapes. Farmers watched its cycles, poets wrote about it. Religions incorporated it into symbols and stories. Entire civilizations organized calendars around its predictable movements. The moon became woven into the human experience. Its presence felt constant, reliable, almost eternal. Familiarity creates an interesting illusion. People often assume that what is familiar must also be understood. Yet history repeatedly demonstrates the opposite. Some of the greatest mysteries are hidden inside the things encountered most often. Familiarity reduces curiosity. The ordinary becomes invisible precisely because it is always there. The moon may be one of the best examples. Humanity has studied it for centuries. Telescopes revealed mountains and craters. Spacecraft photographed every region of its surface. Astronauts walked across its landscape and returned with samples. Laboratories analyzed lunar rocks in extraordinary detail. The amount of information gathered is remarkable, and yet fundamental questions remain. Scientists continue debating exactly how the moon formed. Researchers still investigate the origin of its unusual internal structure. The reasons behind certain geological asymmetries remain subjects of active study. Even now, new data continues to generate fresh questions. The audience is invited to pause and appreciate the significance of this situation. The moon is not a distant object hidden beyond observation. It is Earth's closest celestial neighbor. Humanity has physically visited it. Detailed maps exist for nearly every part of its surface. Despite all that, its earliest history remains partially concealed. Realization produces one final intellectual twist. The moon appears familiar not because it is simple. It appears familiar because it is present. There is an important difference. Something encountered every night feels known even when crucial aspects of its story remain uncertain. The human mind naturally fills gaps with assumptions. We see the moon so often that it becomes difficult to imagine it holding extraordinary secrets. Yet throughout this documentary, those secrets have repeatedly surfaced. A strange crustal imbalance, unexpected simulation results, evidence capable of supporting multiple interpretations, possibility that another moon may once have shared Earth's sky. None of these ideas have produced a definitive answer. The central question remains unresolved. Did Earth once possess a second moon? The honest answer is still the same. Perhaps. The evidence is intriguing enough to keep the investigation alive. The theory exists within the boundaries of serious scientific discussion. It is not mythology. It is not fantasy. It is a hypothesis built from observations, models, and attempts to explain features that continue attracting scientific attention. At the same time, uncertainty remains essential. Alternative explanations exist. Important questions remain unanswered. Future discoveries may strengthen the theory, weaken it, or reveal something entirely unexpected. Mystery survives because the story is unfinished. And perhaps that is fitting. The moon has accompanied humanity throughout history without revealing all of its secrets. It remains both familiar and mysterious at the same time. Closer it feels, the easier it becomes to forget how much remains unknown. As the final chapter continues, the focus gradually expands beyond the moon itself. The mystery of a possible lost companion reveals a larger lesson, one that reaches far beyond lunar history and touches upon the way humans understand the universe, knowledge, and the hidden stories concealed within seemingly ordinary things. The deeper this mystery is explored, the more it begins to reveal something larger than the fate of a possible second moon. It reveals the nature of discovery itself. There is a common misconception that science is a collection of completed answers. Many people imagine knowledge as a finished structure, built piece by piece, until every important question has been resolved. In reality, science is something far more dynamic. It is a process, a conversation that never truly ends. Every generation inherits questions from those who came before. Some are answered, others evolve into new forms, and occasionally, a mystery survives long enough to remind humanity how much remains unknown. The story of a missing moon belongs to that tradition. Whether the theory ultimately proves correct or not, it demonstrates how scientific understanding continues to grow. Ideas are proposed, evidence is gathered, assumptions are challenged, new discoveries reshape old conclusions. History is filled with examples. There was a time when continents were believed to be fixed permanently in place. The idea that entire landmasses drifted across Earth's surface sounded improbable to many researchers, yet evidence accumulated, and eventually a new understanding emerged. There was a time when dinosaurs were viewed as creatures that disappeared through explanations as very different from those accepted today. New discoveries transformed that story. There was a time when black holes existed only as theoretical possibilities. There was a time when planets orbiting other stars remained unconfirmed. There was a time when many ideas now considered fundamentals seemed unlikely. Again and again, the universe surprised humanity, not because reality changed, because understanding changed. The audience is invited to appreciate the role uncertainty plays in that process. Outside science, uncertainty is often viewed as a weakness. People prefer clear answers and definitive conclusions. Yet scientific uncertainty serves a different purpose. It identifies the places where knowledge remains incomplete. It highlights the questions most worthy of investigation. Without uncertainty, discovery would stop. The missing moon mystery illustrates this beautifully. Researchers continue studying the moon because important questions remain unanswered. The evidence has not closed the debate. Instead, it has created opportunities for deeper exploration. Every new observation contributes to a larger effort to understand the history of Earth and its closest companion. Then comes a realization that reshapes the entire investigation. The theory itself is not the most important outcome. The missing moon may prove correct. It may prove partially correct. It may prove entirely wrong. Each possibility remains open. Yet regardless of the final answer, the search has already expanded human understanding. Researchers have learned more about lunar formation, planetary dynamics, orbital evolution, and the behavior of ancient worlds. New questions have emerged. Better tools have been developed. Knowledge has advanced. The journey matters even if the destination changes. This perspective transforms mystery into something positive. Unanswered questions are not failures. They are invitations. Every unresolved puzzle points toward a frontier waiting to be explored. Every anomaly suggests that reality may be more interesting than current explanations allow. The unknown is not an obstacle standing in the way of knowledge. It is the path leading toward it. The audience begins to feel a quiet sense of optimism. The universe is not finished revealing its secrets. Some answers may arrive through future lunar missions. Others may emerge from improved simulations, unexpected observations, or discoveries that no one currently anticipates. History suggests that the greatest surprises often appear where researchers least expect them. The moon may still hold unexplored chapters, so may countless other worlds. Cosmos remains filled with stories waiting to be uncovered. Perhaps that is the most enduring lesson hidden within the mystery. Human understanding is never complete because the universe is larger, older, and more complex than any single generation can fully comprehend. The search continues because curiosity continues. And that curiosity now leads toward one final reflection, where the question of a missing moon becomes part of something even more universal. The timeless human desire to understand the unknown and find meaning within the mysteries that surround us. The story ends where it began, with the moon. Not the moon described in textbooks, not the moon measured by instruments or mapped by spacecraft. Simply the moon that rises above the horizon after sunset, casting pale light across oceans, mountains, cities, and quiet landscapes. The same moon that has accompanied humanity throughout history. It appears unchanged. Ancient people looked upon it. Modern people look upon it. Generations separated by thousands of years have shared the same view. And yet, after following this mystery across billions of years, that familiar sight feels different somehow. The audience is invited to return one final time to the question that guided the entire journey. Did Earth once have another moon? The honest answer remains the same as it was at the beginning. No one knows for certain. Perhaps there was only one moon from the very beginning. Perhaps the geological features that inspired this investigation will eventually receive explanations involving ancient heat patterns, internal processes, or events not yet fully understood. Possibility remains entirely real. But another possibility remains as well. Perhaps the young Earth briefly possessed two moons. Perhaps a smaller companion emerged alongside the larger moon after a colossal impact reshaped the early planet. Perhaps the two worlds shared the sky for millions of years while Earth itself evolved beneath them. Perhaps gravity slowly altered their relationship until a collision became unavoidable. The evidence remains incomplete. The mystery survives. and that uncertainty is part of what makes the story so captivating. Yet as the documentary approaches its conclusion, a final perspective begins to emerge. The most fascinating aspect of the missing moon hypothesis may not be the disappearance itself. It may be what happened afterward. Throughout the investigation, one idea repeatedly surfaced. Certain simulations suggest that the companion moon did not explode into nothingness. It did not vanish into deep space. It may have merged with the larger moon in a slow and ancient encounter. If that happened, the implications are remarkable. The lost moon may not be lost at all. Its rocks could still exist. Its minerals could still exist. Fragments of its ancient crust may still rest upon the surface of the moon visible today. The audience is invited to consider the possibility quietly. The second moon may continue circling Earth every month, not as an independent world, not as a separate object visible in the sky, but as part of the moon itself. The idea transforms the mystery into something unexpectedly beautiful. Appeared to be a story about disappearance, becomes a story about transformation. The world loses its identity yet survives in another form. Companion moon vanishes as a distinct object, but its material endures. Its history becomes intertwined with the history of the larger moon. The ending is not destruction, it is merger. The ending is not absence, it is continuity. This realization encourages the audience to look upward one final time. The night sky appears exactly as it did before the documentary began. The moon remains alone above Earth. Nothing visible has changed, yet perception has changed. The familiar object now carries new possibilities. Beneath its craters and mountains may lie traces of events older than almost anything else accessible to human knowledge. Hidden within its structure may be clues to a forgotten chapter of planetary history. Or perhaps not. Uncertainty remains, and it should remain, as mysteries derive their power not only from answers but from questions. Questions inspire exploration. Questions encourage curiosity. Questions remind humanity that even the most familiar objects can still conceal extraordinary stories. The moon continues its silent journey across the sky. Whether it was always alone or once shared its orbit with a forgotten companion may remain unresolved for years to come. Somewhere within that uncertainty lingers a possibility. A world may have disappeared so completely that only questions survived. And sometimes questions are what keep a mystery alive. The moon rises, the mystery remains, and the story continues.